our galaxy is marvelous and mysterious at the same time. Although we think we know a fair share about the Milky Way, it turns out we're just scratching the surface. With over 100 to 400 billion stars and 1 to 10 trillion orbiting planets, our home galaxy is one massive place. It's bound to have its secrets, and we're bound to come across them sometime or the other. What's been really rattling the brightest minds is at the center of the galaxy. Mysterious structures lie in its depth that scientists don't thoroughly understand. What are these structures, and why are they there? Let's find out. New research has shown that the center of the Milky Way is a powerful particle accelerator. However, there is also some unknown mechanism that is blocking cosmic rays from getting to the central molecular zone, which is a large cloud of molecules at the center of the Milky Way galaxy. This finding could help us better understand the origin of the particles that make up the universe. The galactic center is a zone of mystery. Although we have a decent idea of what's in there, the dust is too thick for us to study it in a range of wavelengths, from soft X-rays through to visible light. Some limitations have been placed on what we can and cannot see. Astronomers think that the center of the galaxy is an important source of cosmic rays. These protons and nuclei that have had their electrons stripped away and been accelerated to relativistic speeds by powerful magnetic fields. There are a few objects in the center of the galaxy that could be used to make cosmic rays: supernova remnants, pulsar wind nebula, and the huge black hole at the heart of the Milky Way called Sagittarius A star. Based on observation data and modeling, the distribution of cosmic rays throughout the Milky Way should be smooth and steady. Cosmic rays are thought to originate in accelerators such as supernova remnants and propagate through the galactic magnetic field. They are then likely slowed and re-accelerated to produce a cosmic ray C. To study the acceleration and transport of cosmic rays, a source of fresh cosmic rays is required. Fortunately, cosmic rays are very energetic. This means that we will be able to detect them in the galactic center because that energy range will produce light in the limited wavelength range that can penetrate the dust there. Cosmic rays can interact with the interstellar medium, gas and dust that hangs around in the space between the stars, and this interaction in turn produces high-energy gamma-ray photons. About 10% of the energy of the cosmic ray parents is carried by the gamma-ray photons. Using data from the Fermi Large Area Telescope, a team of researchers led by Xiaoyan Huang, an astronomer at the Chinese Academy of Sciences, looked at the gamma radiation in the central molecular cloud of the Milky Way to find sources of fresh cosmic rays. They discovered gamma rays that did indicate, as expected, that the galactic center is a high-energy particle accelerator, or at least something in the region is, but they also discovered something remarkable. The team's calculations show that the central molecular cloud has less cosmic rays than the cosmic ray C. This suggests that there is some kind of barrier preventing cosmic rays from penetrating the central molecular cloud. Future research will need to look into what this barrier is made of, but there are a few interesting ideas. Molecular clouds are complicated environments. The collapse of parts of the cloud that are heavier than the rest can lead to the compression of magnetic fields. This could be a barrier. Another possibility could be magnetohydrodynamic turbulence. Here in the solar system, the solar wind modulates cosmic rays. In the center of the universe, the galactic wind could play a similar role. The team performed a calculation to determine the cosmic ray density in the presence of a galactic wind and obtained a similar result to their analysis of the gamma ray data. Future work could help explain this phenomenon more amply and rule out some possible reasons for it. Furthermore, more detailed three-dimensional modeling of the center of the galaxy could help explain how cosmic rays in the Milky Way are made and moved around. The researchers say, "There's always more to be found, and this next one is a tad bit more strange." Apart from the mysterious cosmic ray anomalies, another particularly strange structure has been found at the center of our galaxy. According to another study, a pair of towering, hourglass-like balloons have been discovered at the heart of our home galaxy. the Milky Way. Some of the largest features ever observed at the center were detected by researchers because they were emitting radio waves. To comprehend the scale of these giant bubbles, it is important to remember that they extend for hundreds of light years above and below the center of the Milky Way. How did they get there? Research suggests that a massive burst of energy occurred near the supermassive black hole at the center of the galaxy thousands of years ago. These structures formed because of this. The twin balloons are likely the result of an explosion or eruption that blew through the interstellar medium in opposite directions. The space between the star systems in a galaxy is called the interstellar medium. The researchers think the structures are a few million years old. Ian Haywood, study author and Hintz Fellow at the University of Oxford, said in a statement, "The center of our galaxy is relatively calm when compared to other galaxies with very active central black holes. Even so, the Milky Way's central black hole can become uncharacteristically active, flaring up as it periodically devours massive clumps of dust and gas. It's possible that one such feeding frenzy triggered powerful outbursts that inflated this previously unseen feature." William Cotton, study co-author from the National Radio Astronomy Observatory in Charlottesville, Virginia, further revealed in a statement, saying, "Other scenarios are also possible, including a massive burst of star formation, which sent shockwaves careening through the galactic center. In effect, this inflated energetic bubbles in the hot, ionized gas near the galactic center, energizing it and generating radio waves, which we could eventually detect here on Earth." Even though the structures are huge, it's hard for us to see the center of the galaxy because thick dust clouds hide it from our telescopes. But the South African Radio Astronomy Observatory Meerkat telescope was able to detect radio waves with a wavelength of 800 millimeters emanating from the area. The researchers used the telescope to map parts of the galactic center. When they encounter powerful magnetic fields, electrons accelerate. The signal that the telescope can track is created by this. In addition to its imaging technology, the telescope is also exceptionally sensitive. Steve Bulbus, study co-author and head of astrophysics at the University of Oxford, revealed in a statement, "It is extremely exciting to be able to peer at the center of the galaxy with such high definition and precision. This is the nearest supermassive black hole to us in the universe, and Meerkat has provided us with front-row center seats. We are going to learn an enormous amount about how black holes feed themselves and how they influence their environments." With help from data gathered by Meerkat, astronomers are putting together a fossil record of the history of the galactic center and its supermassive black hole. This will help them understand the history of these things better. The violent event that helped create the balloons could also be the source of the electrons responsible for the radio signal. About 35 years ago, Farhad Yousefzadeh, a professor of astronomy and physics at Northwestern University, found a population of large, thread-like magnetic filaments in the galactic center, 25,000 light-years from Earth. Each filament is approximately 1 light-year wide and tens of light-years long. They have never been observed elsewhere. Yousefzadeh, who is also a senior author of the study, says the radio bubbles discovered with Meerkat now shed light on the origin of the filaments. Almost all of the more than 100 filaments are confined by the radio bubbles. Fernando Camilo, study co-author at the South African Radio Astronomy Observatory, further reveals, "These enormous bubbles have until now been hidden by the glare of extremely bright radio emission from the center of the galaxy. Teasing out the bubbles from the background noise was a technical triumph, only made possible by Meerkat's unique characteristics and propitious location in the southern hemisphere. The researchers believe this discovery and the Meerkat telescope herald a new era of radio astronomy, and with newer telescopes, technologies, and methods of understanding, we may get the answers sooner rather than later." Whether it be mysterious galactic shields that block cosmic rays, or massive balloon-like structures at the center of the galaxy, one evident thing is that we don't nearly know as much as we should about our cosmic neighborhood. It wouldn't be surprising to come across even more mysterious structures in our galaxy. So, what do you think? What really lies in the central molecular zone? And what really are these balloons at the center of our galaxy? Let us know in the comments below. And as always, thanks for watching Space Age.